as I said yesterday, we were going to learn today how to deal with these properly. And that's what we are going to do right now. And it will literally take one example, because you will see how easy it is, and you'll be like, oh, okay. So Rob already knows how to do it. He figured it out yesterday. But there's a little bit of terminology that I want to get to here. So we're going to do that right now. A radical is where's my pink? A radical is an expression with that symbol. You guys call it the square root symbol probably, but it's not. It's the radical sign. And it isn't always square roots. What it really looks like is this, and I want you to draw the whole big thing. X root y. And we already talked about what that little number means, right? So now we're just going to name those little numbers. And I've already named these two, but I want, again, to reinforce this because I like to use the real words. The X is what? Index. And the Y, who remembers? Maybe I didn't say it to this class because I'm teaching this to everybody right now, is what we call a radicand. Now, remember back in grade 3 when you learned what the divisor and the dividend and the quotient was, and all those weird words for those proper words for the things in math, and then you promptly forgot them because you never had to use them again, right? Well, back then it wasn't a big deal because there was only like 2 or 3 things you were ever doing. But now I got to use this word a lot because we're going to be doing a lot of work with the expression that lives under the radical sign, which is officially called a radicand, okay? All right, an entire radical. Entire is just a radicand. So that's all that there is to it. A mixed radical is a coefficient. I put 2 I's in coefficient. I don't know why. A coefficient and an entire radical. So I've drawn this over here because I wanted it to be above mixed radical. The coefficient, of course, lives right in front. That would be A. What do coefficients do? Multiply. All right, so everybody knows what a coefficient does. This is a mixed radical. That's why I highlighted that in blue, and that's why I highlighted that in blue, because it's got a coefficient. Now, our goal is 99% of the time, we want to convert entires to mixed. That is our usual goal because mixed is simplified. Now, sometimes we have to use entires. So you got to be able to work back and forth between the two. And that's what you're going to see by that line I drew. Okay? You're going to have seen how to go from entire to mixed and mixed to entire. And then I'm going to shut up and then we'll have some chill time because it's Friday and it's gross out. Yeah? Yeah. All right. So we already did this a couple of days ago. That was the very first example I gave you because it's not a square root, right? And we talked about how to estimate it, and we talked about using our calculator to find the answer. And when we use our calculator to find the answer, we get a big, long decimal. How do I feel about decimals? Blech! So, we hate decimals because decimals are basically saying, I think it's kind of close to this, but I'm not totally sure. And if I wanted that, I'd go back to kindergarten where I was teaching addition, where the kids could go 2 plus 3, 5, like a question. I got no time for that. I want answers, right? There's enough questions in the world. I want answers. So as a result, this is what you are going to do from now on when you see this. You are not going to hit the square root button and get 8.48 blah again this year at all until that unit. That tab right there. Okay? We're on this tab right here. Alright? Alright. So here's what we do. There's two ways to do it. There's one way that always works. Everybody can do it in their sleep. And then there's a little shortcut that you can do if you paid attention to me and actually memorized your perfect squares. Okay? Of course, which way do I show you first? The long way that always works no matter what. Right? Because that's the way you got to know. Now, here's what you do. I look at this, I say self, that's not a perfect square. Right? And we already dabbled with this in the last exercise I gave you. We got to break it down into smaller numbers. So what we do to break that down is we prime factor. Now, somebody in the class was asking about prime factors because I drew a factor tree when we did this. And that's cool, right? Most kids like factor trees. They have fun with it. Oh, it fills up the page. It's pretty. I get a gold star from Mrs. Bad Grumble. Some of you are like, I don't like drawing factor trees. I want to draw it like a ladder. I don't care. Okay? So you have already seen this. 72. What's that break down into? 9 and 8. Are either of those prime? No, so we break it down again. 3 and 3. 2 and 4. And we break that down again to 2 and 2. Right? Now some of you will then maybe want to do this. 72 divides by 2. 36 divides by 2. 18 divides by 2. 9 divides by 3. 3. I don't care, because what happened right there and there? I got the same numbers. I don't care how you factor it. What's important here is you recognize that, and I'm going to get another color going. What is important is you recognize that the square root of 72 also equals the square root of 2 times 2 times 2 times 3 times 3, which also equals the square root of 2 cubed times 3 squared. Right? Now, you're intelligent young people. The index here is what? 2, because that's the smallest index you can have. We don't bother writing it, because it has to be 2. You can't have an index of 1, because 1 is not a group of factors, right? So this means I'm looking for groups of 2. Is there a group of 2 I can get there? How many groups of 2 can I get out of 3? I can get out 1 group of 2s, yes? So that means I'm going to bring out that single group of 2s. How many 2s were left there? 1, because there were 3. I took out 2 of them. So there's a 2. Can I get a group of 2 out of there? I can get out a 3, yes? Now these numbers have gone into the place of the A, right? What do coefficients do? So what is 3 times 2? So the answer is 6 root 2. And that is how you will do these from now on. Everybody cool? All right, now, I promised a shortcut. Here's the shortcut. Shortcut color will be dark green. 72 breaks down into 2 and 36, yes? So that is really the square root of 2 times 36, right? What's the square root of 36? 6. So what comes out? 6. Leave me with 6 root 2. If you are factoring and you come to a perfect square and you're doing square root, you could stop. What if you were doing cube root? When could you stop? At a perfect cube. Everybody cool? So let's look at 99. What should be the first 2 factors I use? I should use 9 and 11. Why? Well, first of all, that's the only factors it has. But it also has 3, right? 3 times 33. But why would I use 9 and 11? Because what's special about 9? It's a perfect square. So this root 99 is really the root of 9 times 11, yes? Which is really the root of 9 times the root of 11. And what is the root of 9? 3 times the root of 11. Now, does 11 have a root? So we leave it there. Because it doesn't have a square root, and we don't want decimals. Everybody cool? So you can do, this is what is really happening. The shortcut is you take the square root and you bring it out to the front. That's it. Everybody cool? So what could I use for 75? Now most of you are going to say, oh, I got to factor 75, it ends in 5. I'm going to divide by 5. Right? And that would get you 5 and 15, yeah? But is there a perfect square that works with 75? What? Yes, because this is 3 times 25. What is the square root of 25? So what comes out? 5. What stayed under there? What stayed under there? What stayed under there? Thank you. Man, how hard is it? I made you already say underwear.
We thought you were wrong, so we thought you were getting mad.
Obviously, I'm going for the cheap laugh. You've been here long enough to know. Okay, now, let's pretend that you didn't listen to me. Let's pretend that you're like, I'm not going to memorize nothing. He can't make me. He's not the boss of me. Okay, kid. 5 and 15. 5 and 3. There's your pair of 5s. Out it comes. Okay? If you don't want to bother memorizing your perfect squares and perfect cubes, the only thing that does is make your work take longer. Right? Okay. So, what am I going to do with 80? What? You could do 10 and 8. Okay? Is either one of those a perfect square? So what are you going to break down next? 8 is going to be 2 and 4. Are you going to stop there? Isn't that a perfect square? Yeah. So can I stop there? Yeah. Okay. Isn't that prime? So can I stop there? Yeah. Okay. So should I do anything with 10? What should I do with 10? To what? 2 and 5. Do you see your pair? What is it? 2. So what's coming out? What else is coming out?
2.
Another 2, because I want the square root of 4, don't I? Because this is all square rooted, right? So I got a 2 and a 2 out there, so what happens with them? To get?
4.
And what stayed under there? What stayed? 5. Okay? Now, of course, if you're good with your times tables and you practice a lot, you would know that 80 also equals 16 times 5. But that's off the 12 times table, right? For some reason, we decided when we were teaching you guys times tables in grade 3 or whatever, that we'd only go to 12. Apparently, all the numbers stop at 12. I don't know why we stopped at 12 instead of 10, which would have made sense, right? Or why we didn't carry on past 12 to maybe 20, which would have made sense. But for some reason, we stopped at 12. I don't know why. I have no idea why. But anyway, what are we going to do with 300? What are we going to do with 300? Armand? Of course you're going to do 3 and 100. Why would you do 3 and 100, not 2 and 150? Because 100 has a perfect square. What is it? 10. Leaving what? 3. Does everyone see how easy this is? Jordy.
You could also do 15.
You could do 15 and 20.
25.
Yeah, you could do 25 and what? 12. So let's just do that, shall we? So if I use 25 and 12, a great many of you are going to pull out that 5 and you're going to leave the 12. Because you're going to forget that 12 is 4 times 3. So you got to bring out another 2. Picking up what I'm putting down? You can use 25 and 12, but that's what often happens when kids do 80. They do 8 and 10, they stop at the 4, and they tell me the answer is 2 root 20. But that, of course, is wrong. Well, that's the wrong word to use. It's not wrong, is it?
It's not quite right.
It's just not simplified enough. Right? Everybody good? All right. What are we doing with 63? 7 and 9. Why?
Because 9 is a square.
So what's the answer?
3 root 7.
3 root 7. What are we doing with 32?
16 and 2. I was going to say
What are we doing, RJ?
16 and 2.
Yeah, we're doing 16 and 2. Why?
So 16 is square.
So what's the answer?
4. 8 root 4. 4 root 2.
4 root 2. What are we doing with 363?
3 and 121.
3 and 121. Why?
121 is perfect square.
What's square root of 121?
11.
Wow. Now, just for fun, and I know some of you have already done it, what's the square root of 1728?
Isn't it like 51? My bad. What?
No, the cube root was 12. What's the square root of 1728? I know it's irrational, but that doesn't mean anything to us anymore because now we're simplifying to that. So what am I doing with 1728? I know, right? If you can do 32, you can do 1728. Why? What's the first thing you're supposed to do? We break it down. I don't even know where to start, Mr. Myers. Start with the simplest thing you can. It ends in 8. 2. How many 2's go into 17? 8. With what remainder? 1. How many 2's go into 12? 6. With what remainder? 0. How many 2's go into 8? 4. There's our first breakdown. I got a prime number. What's that end with?
4.
So what are we going to use?
4. 2.
2. 2 goes into 8 how many times? 4. 6.
3.
4.
2.
What's that end with?
2. Divided by 2.
2.
That goes into 4 twice. And then it goes 32 16 times.
Then what?
And 6 divided by 2. It goes into 2 once. And 16 times.
Now at 108, I'm going to stop for a sec. Because I know that 108 is 9 times 12, yeah? There's a perfect square. And I know 12 is 4 and 3. There's a perfect square. So what am I looking for here when I have no index?
2.
I'm looking for 2's. Is there one? So out comes a 2. Is there one? So out comes a 2. What's the square root of 9? 3. So out comes a 3. What's the square root of 4? So out comes another 2. What do I do with all that? What is it? 24 root. What did I leave under there? 3. So that is our new answer to that. Okay? Everybody understand? Does it matter how big the number is? No. Right? You can always break it down unless it's a prime number, right? Right? Because prime numbers aren't going to break down. Sweet. Okay. Now, we're going to do these 4, and then I'm going to be done. Right is an entire radical. So I'm going back the other way. Right? So we think to ourselves, self 2 root 5. If there is a single 2 out there, how many 2's are under there? Root 5 times 2 squared, which is root 5 times 4, which is root 20. Everybody cool? Okay. 7 out there. How many 7's were under there? Square root 29 times 7 squared, which is square root of 29 times 49, which is square root of 1,421. 1,421. Yes. Yes. Do you want to know how I do those?
Yes.
No.
Yes.
20 times 40, 20 times 9, 40 times 9, and 9 times 9. 20 times 40 is 800 because 2 times 4, 2 zeros. 20 times 9, 160. 40 times 9, 360. 9 times 9, 81. Then you add it up. Or 180, sorry, 180. Then you add it up. That's what I do.
Is it just like a skill, or
Practice. Just practice. So what's this one? Which is also what? 12 is the answer there, right? And that makes sense because what is the square root of 4? So what would come out? Did I leave anything under there? No. Good. Now, 5 screws kids up. Everybody try, or D screws kids up. Everybody do D. See if you can get it right. I'll wait a couple of seconds. Ooh, I got a new subscriber. Ooh. I got 2 new subscribers over the last 2 days. I think I'm up to 235.
let's go. You're popular.
Huh? No. I get paid to be a teacher. I don't get paid for my YouTube. Which is funny because the jokes I make on my YouTube channel when I teach you people, plus the teaching, is actually kind of useful for a whole lot of people. But I don't get any hits. If I was putting on makeup, I'd have 1 million hits.
You should start putting on makeup.
I should be an influencer. I refuse to be because that is a title that if I could erase it from the English language, I would. Because really, if you're going to influence anyone, shouldn't you have something useful to say? And correct me if I'm wrong, but I believe Logan Paul has nothing useful to say.
I mean, you're not wrong.
I know I'm not wrong, and yet, how many followers does that clown have? Huh?
One too many.
Yes. No, he has 1.1 billion too many. Because he should have none. Except maybe his mom, because your mom is like, "You're awesome!" all the time. My mom wasn't. If I sucked at something, my mom was like, "Why are you bothering to do that, you idiot?"
Same here, man. Same here.
And then if I thought I was good at something, but I wasn't really, my mom was like, "You better practice, because you're not as good as you think you are." Love my moms. I only have one. But, you know. All right, what's the answer?
Negative root 300.
That's the stuff, Jewel. Negative root 300. A lot of kids think, oh, okay, well, there's a negative 5 out there, so there must have been negative 5 squared under there, which would be the root of 300, right? But it can't be the root of 300 because I need that negative sign. It's just like exponents. This is its own thing, and the negative is out in front. So you have to keep that negative there. Jordan.
So what if negative 5 was in brackets?
You can't do that.
Right.
Because, well, I shouldn't have said that. If you had this, it would technically be 12 times negative 5 squared, which would get me the root of 300, right? Okay. Here is why that is an issue. Erase my...
Quick math.
What is the square root of 25? I lie. How many square roots does 25 have? Wrong. 2. Because the answer to this is really plus or minus 5, isn't it? Because negative 5 times negative 5, same thing, square root, gets an answer, yeah? Okay. But here's the problem. This expression has a negative value, yes?
Yes.
Which means I got to leave that negative out in front. Okay? So now, technically, anytime you're asked for a square root, you should include the negative one. But in math class, by convention, we are usually looking for the positive square root, which we call the principal root. Now, sometimes the negative will come into play, and you will learn about that next year. But for the most part, we are seeking the positive square root. Okay? Or the principal root, to be precise. Now, I am done. Your job, and I don't care if you work on it right now or not. Oh, I'm the worst kind of liar. No, I'm not the worst kind of liar. You are going to attempt those. You're going to attempt them, and you are going to work up to the end of page 41. Now, again, it is 9:10. You will notice I've left a lot of room here. Why?
Because it's going to be a lot of work.
No, it's not a lot of work, but if you screw up, you need room to fix it. Okay? But remember, if something works once in math, how often does it work? Always. Okay? So, I know it's Friday, and I know we should be chilling and hanging with our homies, but we're not. You can work on this. I expect to see it ready to rock by Monday. If you are looking for extra practice, page 42, you may want to have a look at that. Again, you can see that all of these number ones are just like the notes. Right? Now, the notes have no answers, so you're going to attempt that. Yeah? And then check a few of these to make sure you're doing it right. Do you have to do all of them? No, but if you do all of them and simplifying radicals becomes automatic, like multiplying 29 by 49 is for me, then are you in better or worse shape? Better. Right? But mathematically speaking, are you any better off? Not really. Right? But skill-wise, you are. Now, again, I remind you, the more stuff you can do automatically, the less trouble you're going to have with higher level math. Does everyone understand what I am saying? If you are wasting your brain power to do 6 times 12, and it's the first step of 40 steps, you're going to be in trouble in grade 11 and 12. Okay? This stuff, get it to be automatic. Right? And the way to get anything to be automatic is practice. No matter what anyone says. Okay? Okay. Go. Maybe at 9:20 in 8 minutes, we'll have a little more Pictionary time. I know the game should be based on math, but
I mean, that cube root or square root is pretty math to me.
I'm feeling kind of blah because of the weather and such, so. Got a magic 8 ball there?
Yeah. What am I doing?
It's funny that you people are still using those things. We were using those things.
Dang it. What does that mean I am? My mom's not even home tonight.
So the chances of getting pizza are better, I would argue, if your mom is the main food provider.
My dad is.
So then why wouldn't you get pizza? You have to feed yourself, so get what you want. Call Domino's and bring me pizza. No, Domino's is not. Domino's is garbage. It's garbage. It's garbage. It's better than it used to be. It used to be super garbage. Domino's even had a commercial campaign where they talked about how bad their pizza was, and we've listened to you and we've improved our pizza. And they did. Domino's is better than it used to be. Now, if you have to eat gluten-free, Domino's is one of the better places to get your pizza. Well, gluten-free. It's not really gluten-free because there's flour everywhere in a Domino's restaurant. But